I'm Nana Manori, working as Assistant Professor in the Department of Civil Engineering, SVIT Bangalore. I'm the course coordinator for Advanced Surveying. Module 1, Trigonometric Leveling. To determine the elevation of the top of the chimney, the following observations were made. Instrument station, it is at A. Reading on the benchmark is 0.860. Angle of elevation, it is 18 degree 36 minutes. And when the instrument station, it is at B, the reading on the benchmark, it is 1.220 and the angle of elevation is 10 degree 12 minutes. And the RL of benchmark, it is 420.500 meter. Station A and B and the top of the chimney are in the same vertical plane. Find the elevation of the top of the chimney if the distance between A and B is 50 meter. Okay. See, I have wrote the figure here. Okay, you can observe here. See here, when the instrument station, it is at A. This is the ground profile. Instrument station, it is at A. The angle of elevation to the top of the chimney, it is, okay, it has been reached here, okay. I made a mistake here, make a correction over there. Angle of elevation to the top of this chimney, it is alpha 1. Similarly, when the instrument, it is at B, okay, the angle of elevation to the top of the chimney, it is denoted by alpha 2. That will be equal to what? 10 degree 12 minutes. Similarly, alpha 1, it is 18 degree 36 minutes. Okay, and the distance between A and B they have given, that is what? 50 meter. Okay, and the staff reading when the instrument, it is at A, which is taken on the benchmark, it is denoted by S1. That will be equal to what? 0.860. Similarly, when the instrument, it is at B station, the staff reading taken on the benchmark, it is denoted by S2. It is given by 1.220. And they have specified in the problem the station A, B and the elevated object, that is chimney, are in the same vertical plane. Okay, are in the same vertical plane. And you can observe here the staff reading. The staff reading when the instrument, it is at A, it is lower compared to the staff reading when the instrument, it is at B. The staff reading taken on the benchmark, okay, it is higher. You can make it out here. Okay, the instrument station B is higher than A depending upon the staff reading. Okay, you can observe here that is the staff reading when the instrument, it is at B, it is higher compared to, that is A. Okay, it belongs to what? The case base of the object inaccessible, that to what? It belongs to second case. Okay, that is what? The instrument B is higher than A. You need to calculate what? The distance between from the instrument station A to an elevated object, and also you need to calculate this RL of this elevated object. In order to calculate this RL, you need to calculate, that is H1 and H2. Okay. First step. You need to calculate the distance from the instrument station to an elevated object. Call that distance as D. You need to calculate this D as well as the RL of this Q. Okay. Okay, I will write it here. That is S1 value is 0.860 meter. Similarly, S2 value, it is 1.220 meter. Here what? S2 is greater than S1. Okay, that is what? Instrument B is higher than A. Higher than A. Okay, next you need to calculate, that is the distance. Okay, distance equation, it is given by, when instrument B is higher than A, distance equation, it is given by B tan alpha 2 plus S divided by tan alpha 1 minus tan alpha 2. This is the equation. Okay, first you calculate, that is the staff intercept. S equals to what? Difference of what? Two staff reading. which is higher value is subtracted. S2 minus of S1. S2 value it is 1.220 minus 0.860 meter. Okay. Upon simplification, you will get it the staff intercept as 0.360 meter. Then substitute the value D equal to B value is what? Distance between two stations, that is A and B. They have given in the problem, that is 50, and tan alpha 2. Alpha 2 is what? Observations. Angle of elevation when the instrument it is at B, it is 10 degree 12 minutes plus S value it is 0.360 divided by tan of alpha 1. It is tan alpha 1 is, you can observe here, tan alpha 1 is 18 degree 36 minutes, alpha 2 is 10 degree 12 minutes. Okay, alpha 1 it is 18 degree 36 minutes minus tan alpha 2 it is 10 degree 12 minutes. Upon simplification, you will get distance D value as 59.60 meter. Once you calculate, that is the D value, calculate H1 and H2. Okay, H1 it is given by D into tan alpha 1. Substitute the value D, 59.60 into tan of alpha 1 it is 18 degree 36 minutes. Okay, then you will get it as H1 as 20.06 meter. Okay, next you calculate H2 value. H2 will be equal to what? B plus D into tan of alpha 1. Okay, that will be equal to B is 50 plus D is nothing but your capital D. You can write it as capital D itself. Okay, that is 59.60 into tan of alpha 2. Sorry, that is tan of alpha 2 it is 10 degree 12 minutes. Okay, upon simplification, you will get it as H2 value as 19.72 meter. This is what? H2. Once you calculated H1 and H2, you can calculate RL of what? Chimney. That is RL of Q. RL of Q will be equal to, RL of Q equals to, you can observe here in this figure, you want this RL of this elevated object. Okay, extend this line up to here. Okay, this should be here. Okay. Okay. RL of Q you want it. Okay. How we are going to calculate RL of benchmark they have given? It is 420.50 meter. Okay. By taking the reference of RL of benchmark, you need to calculate RL of this Q. When the instrument it is at A. Okay. That is what? RL of benchmark plus the staff reading on the benchmark, that is S1. Okay. From here we reached, you need to reach top of the Q point plus H1. I will repeat it, RL of benchmark plus staff reading S1 plus H1. Okay, that is what your RL of Q. That is RL of benchmark plus staff reading S1 plus H1. RL of benchmark plus S1 will be your RL of instrument axis. I have substituted directly here. Okay, then substituted RL of benchmark, it is 420.50 plus S1 is 0.860 plus H1 it is 20.06. Upon simplification, you will get it as RL of top of the chimney as 441.420 meter. This is what? RL of Q. Okay, you have calculated RL of Q when the instrument station it is at A. Similarly, you can apply the check by considering the instrument station it is at B. Okay, you should get the same value. Check you can apply here. Okay, same you calculate RL of Q by taking the reference when the instrument it is at B. Instrument station it is at B. Calculate the RL of Q. That is what? RL of benchmark plus S2 plus H2. Okay. That is RL of benchmark plus S2. It is nothing but RL of instrumental axis plus you need to add H2 here. RL of benchmark it is 420.50. S2 value it is 1.220 plus H2 value it is 19.72. Upon simplification you will get it as RL of Q as 441.440 meter. You can observe here RL of Q you have calculated when the instrument station it is at A, you got it 441.420. Similarly you need to apply the check by considering the instrument station at B. Same way you have calculated RL of Q, obtained value it is 441.440. The same similar value obtained it. Okay. What you have calculated RL it is correct. Thank you.